All right, how to determine algebraically if we have a one-to-one function. What we need to do is set up an equation where we put x1 on one side equal to x2 on the other side. And we are looking to see if there is any possible way that these two will not equal each other. If there's any way that those two won't equal each other, then we're out of luck. So if I subtract 1 from both sides, they cancel, and I've got x1 minus 2 quantity squared equals x2 minus 2 quantity squared. Now, when I take the square root of both sides, remember that the square root could be either positive or negative. So on this side, let's say we have plus or minus x minus 1 minus 2 equals plus or minus x2 minus 2, right? So basically, this is giving us four options right here. It is saying we could have positive x1 minus 2 equals positive x2 minus 2. We also could have positive x1 minus 2 equals negative x2 minus 2. We also have negative x1 minus 2 equals positive x2 minus 2. And it could also mean negative x1 minus 2 is equal to negative x2 minus 2. So this is how we'll algebraically figure it out. Now the key is, are there any of these options which don't work? So if we had distributed this negative or the positive through up here, we would add 2 afterwards and we would say x1 equals x2. It's all hunky-dory. It's fine. But this next one, when we distribute this negative sign through, we've got x1 minus 2 is equal to negative x2 plus 2. And we end up, if I were to use that one down here, as an example, I would have negative x2 plus 2. And so now actually, in order to try to get these things to equal each other, I'd have to subtract 2 from both sides. And I get x1 minus 4 equals negative x2. And there's no way, even if I divide out a negative, there's no way that those two sides are going to equal each other. So I'm kind of out of luck to say, okay, this is actually not equal. So in this case, and this case, those are not equal to each other. This one would be fine also, but if we have even just one algebraic solution in which the x1 does not equal x2, it is not a one-to-one function. So that is how you'll do it algebraically. Now this is redundant. All you'd really need to get to is to get to this point and say, okay, x1 minus x2 is not equal to negative x2 minus 2. This is all you'd really need to say to go straight from here to here. I just wanted to show you all the four different options that we could potentially have. But that one is enough to say. So let's look at 17 real quick as well. 17 is x cubed minus 1, right? So we're going to do the same thing where we've got x1 cubed. Now this whole thing needs to be cubed. Minus 1 equals x2, the entire thing is cubed, minus 1. Now, I'm trying to see, okay, are these two sides equal to each other in every possible way, right? So I'll add 1, they cancel off from either side, and I've got x1 cubed is equal to x2 cubed. Now, to get rid of that cubic function, I have to take the cubed root, but like up above, when we took the square root, if you have the square root, 2 is a solution of the square root of 4, but also negative 2 is a solution to the square root of 4, right? Which is why I have to include just a simple plus or minus 2, right? But when I'm dealing with a cubed root over here, there's actually only one solution. So if I say, what's the cubed root of negative 8, I can actually do that math and say, no, it's just going to be negative 2. There's only one number that will multiply by itself 3 times in order to give me a negative 8. Same thing with the cubed root of positive 8, okay? Only positive 2 is that, because if I put a negative here, that oops, let me include that cubed root. That would make it -8, right? So this, in fact, is, I don't have to include, or I can't, I would be incorrect to include a plus or minus. So in this case, I find that x1 does equal x2. And that means this is a one-to-one function. So there's some help on 12 and 17. Hopefully that helps you out for the test tomorrow.